Hello, everyone. Today I'm going to talk to you about the access to medical oxygen in the Americas. I'll start with the Lancet Global Health Commission on oxygen security. Then I will explore engineering as workforce in hospital field, how engineering can help to promote a rational, sustainable, and safe use of oxygen. Then I will explain a little bit about the oxygen devices and in oxygen infrastructure and how engineering services are impacted by regulatory, demographic, economic, and technological forces. And finally, I will make some suggestions. Oxygen is an understudied topic. It's an urgent health issue and requires scientific review and much more research on how we are using oxygen in daily basis. The Lancet Global Health Commission has four lines of research and four transversal pillars, and I will talk to you about oxygen access in health systems focused on biomedical workforce and devices and infrastructure. Oxygen is a healthcare technological resource, and since its incorporation, we have been using it massively. As oxygen has no obsolescence, it's important to increase the effectiveness of use, to increase the benefits in real conditions. To better use the oxygen in hospital, it's important to understand its life cycle. There are a lot of equipments and infrastructure that we use to offer oxygen where and when it's necessary. That's why it's important to understand the large amount of knowledge that engineering professional must have, not only thinking in theory, but also in practice. For example, tuberculosis patients and COVID patients must have the mixture of gas they use treated before sending it to the atmospheric air. But during the pandemic, hospitals started producing its own oxygen. That's why it's important to offer adequate tools to engineering professionals in order to guarantee not only the amount of oxygen, but also to guarantee the purity of oxygen that are using in hospitals. An engineering service will be successful if it helps the administration to reduce the pressure created by demographic, regulatory, economic, and technological forces. Engineering is a legally qualified profession in many countries. There are many professional modalities working with complementary knowledge. It's important to understand that craftsman is the major part of engineering workforce inside hospitals. But what happens is that engineering is a term that's not used commonly in hospitals. Normally, they use maintenance, but it's important to understand that maintenance is a part of engineering and not an engineering itself. You can check this doing a search in the internet, and you'll find a lot of organogram of hospitals showing that what I'm telling to you. It's important to understand that this medical equipment has different proposals, different operating principles, costs, associated risks, and it requires specific tools and knowledge in order to manage these equipments. Besides medical equipment, we have all infrastructure related to oxygen. For example, electricity or solar panels to be used along PSA plants. We have different types of storage systems in high pressure, low pressure, in liquid state. For example, we have the different distribution pipelines types for vacuum, nitrous oxide, and etc. That's why it's important to professionalize the engineering professional working in health sector. The liquid measurement process have not evolved, even if during the pandemic. To measure it correctly, it's important to understand that there are concepts related to thermodynamics with transmission and fluid mechanics. It's not common to find hospital monitoring the pressure of vapor and hydrostatic pressure inside cryogenic tanks. For example, with a simple task to measure the vapor pressure and hydrostatic pressure. The only thing we have to do is to measure the vapor pressure and hydrostatic pressure in the manometers I have shown to you and use the specific table of the tank to know how much oxygen there are inside. But it's important to understand that there are tables offer more information and more flexible to work than others. The table in the right is better than the table in the left side because we can measure the amount of oxygen considering right vapor pressure in the moment that I'm doing the measurements. So we have to choose suppliers, for example, that can offer us tables like this. Hospitals must control their oxygen demand more accurately. To buy more oxygen than use, probably the hospital will lose oxygen by evaporation. The process of measurement of oxygen in gas state has not advanced. Hospitals normally didn't do it very well. They don't use technical information to do these measurements. Normally, the hospitals receive the oxygen, store, consume, and it's a kind of cycle that do not provide good information for administrative purposes inside a hospital. There are different sizes of cylinders, and the only thing you have to understand or to know is the pressure inside this cylinder. It's important also to evaluate the risks this type of installations offer to hospital construction. And besides the pressure, you must know the volume, the internal volume. The market has been doing an effort not only for industry but also for healthcare providers in order to facilitate to measure the amount of oxygen inside a cylinder. But there are a more simple process that can be used by both engineering professionals and healthcare professionals. The only thing we have to know is the internal volume in liters and the pressure work, in this case, 150 bars, in this case, 200 bars. And volume is, in this case, 40 liters, in this case, 50 liters. Doing a simple multiplication, you can do it in a simple way. That's why it's important to teach. It's everyone's work. By doing this, you can generate useful information. Sometimes we find a large amount of data, but it's not useful. It not provide confidence in decision making. So it's important to apply these two methods for liquid or gaseous state oxygen to understand better how much do the hospital buy, how much do the hospital consume, and so on. In the case of PSA plants, besides volume and pressure, we must measure flow, air and oxygen purity, in addition to contaminants. The management of a PSA plant also requires that engineering professionals manage the electricity. Electricity is the main cost of oxygen production, besides maintenance. It's highly associated with sustainability of this type of technology inside hospital. It's not common to find hospitals measuring its electricity bills. These bills normally are paid by a central health system, and hospitals are not used to measure it, and they don't know how much they pay for energy. It's important to understand that small units, basic health units, normally pays for a kilowatt hour, but in large hospital, they can pay binomial rates, paying for kilowatt hour in kilowatts. And this price may change between the time of day or during the seasons. To manage electricity is a part of economic sustainability, and it will help us to know the total cost of ownership. That's why it's important to disseminate technical information to help hospitals to understand all the costs before adopting one technology or other. It's also important to use engineering knowledge in this type of studies. Good shopping means good specifications. An oxygen cylinder may have 24 technical information, but it's important to understand that at least you have to define pressure, volume, color, and type of connections. It facilitates technical communication. Sometimes you want to talk or help a colleague in another country or in other hospital, and the communication are very compromised because the lack of correct data or correct information. It's important to specify the colors. Countries have to decide which color they will use for oxygen cylinders. In this case, you can see different types of colors used to store the same gas. It increases the risks of cross connections. That's why we have to standardize not only colors but also connections. There are basically two types of connections that we use, but when you have two different types of connections in the same hospitals, you will increase the number of parts or spare parts to manage. The number of accessories increases too much. The same thing may occur in oxygen outlets. If it's not standardized, the same problem of duplication will appear in hospital and will increase the work or the tasks that engineering must do to manage these devices. This is an example of two flow meters that do the same thing but with two different types of connection. The lack of specialists may lead to the substitution of a system like this that permits to manage it not only primary and secondary supply and to regulate the pipeline pressure by systems like this. That's more unsafe because there are only one pressure regulating station. We have to improve the process of commissioning. One company do the design, the other company do the installation, and other company or the engineering of hospitals do the commissioning. Working with specialists can reduce this type of risk. It's also possible to find oxygen pipelines constructed using plastic tubes inside copper tubes. You can find also medical compressed gas using plastic pipelines. It's important to understand that medical air is used along oxygen or nitrous oxide in anesthesia machine or mechanical ventilators. Other very important point to be considered here is how we manage the oxygen pipeline pressure. Engineering must know how this simple equipment works in order to regulate the right pipeline pressure. Medical equipment such as mechanical ventilator or anesthesia machine normally works using a range of pressure, not a specific value. But in the case of flow meter pressure, they are calibrated to work in a specific pressure. We can find in Americas basically two values of pressure, or 50 psi or 60 psi. That's why we have to pay attention in what type of flow meter are we using and what is the pipeline pressure. This is a study that I realized in Brazil in a city with 2 million inhabitants. All hospitals are public. We measure the vapor pressure, hydrostatic pressure, evaporator pressure, and pipeline pressure. Look, in Brazil, our flow meters are calibrated to work in 3.5 bar, but all hospital had its pipeline pressure higher than necessary, from 51% higher to 126% higher. Imagine the amount of oxygen that are being lost because of this. Because when you adjust, for example, 5 liters per minute in a flow meter, this information will not be true. So healthcare professionals use more oxygen than the patient needs. It's easy to identify this. Just go to the nurse station and look for the pipeline pressure. If it's right, no problem, it's good. If it's higher than necessary, you must reduce the pipeline pressure. That's why it's important to assess the current situation, to start with an alarm program, for example. Not only the alarm, the operation that informs engineering that there is a problem, but also the emergency alarm created to be used for healthcare professionals. And start answering questions and create a strong safety program. You can also identify the risk of falling cylinders. There is a risk of fire associated to oxygen outlets in oxygenotherapy devices. There are risks related to cylinder accessories and risks associated with gasotherapy devices and accessories. Besides this, there is the risk of cylinder explosion with no fire. There are risks of ferromagnetic attraction created by MRI equipment, lack of adequate resources during transportation, including risks associated with patient transportation or during the tasks of cylinder transportation. As a suggestion, I can say establish a person legally qualified to manage oxygen, probably a pharmacist. Provide work tools to the person in charge. Provide work tools to the person in charge. Engineering may be a very good support to pharmacists in order to start a very strong oxygen management process. Focus efforts on the use. We are not using oxygen well. That's why we have to increase ways to show how oxygen can be better used inside hospitals. It's very important to create performance indicators. There are a lot of them that can be created to specific tasks, but it is important to compare the amount of oxygen a hospital purchased compared with the prescribed and effectively administered oxygen to patients. Besides the creation of performance indicators, it's important to compare your data with other hospitals. It's important to make benchmark. Hospitals must start to map and understand the risks related to oxygen processes. There are hidden risks that must be studied in details. Doing this, the oxygen management process will be safer, not only for patients, but also for workers, for visitors, in the place where a hospital is constructed. It's important to adopt standards. If your country doesn't have a standard, you can use international standards, but it's important to understand that a good purchase starts with a very good specification. It's important to have a plan, even if you don't have money. If you have a very good plan, when you have the resource, you can put it in practice. In doing this, you can speed up the process of implementing the public budget. Besides to buy, know the hidden costs. Always there are hidden costs. It's important to know them before purchasing. Be informed and make a good gas supply contracts. Know the associated costs. Besides to know the costs, it's important to practice to distribute these costs across the cost centers. But the more important recommendation is to professionalize the performance of engineering and architecture in hospitals, and also to strengthen the artisans or craftsmen. They are the largest engineering group presented in hospitals. Donors must ensure the effectiveness of donation. They must understand what is going on in the hospital. What are human resources, the environment, the material resources that is necessary, if they have resources for maintenance, if the equipment or system donated has a financial viability, and etc. For NGOs, it's important that NGOs work as a team to avoid diffuse efforts. Sometimes in the same country are different NGOs working there, and it's important to concentrate efforts to improve oxygen management, not only in a specific hospital but all over that country. For patients and family members, it's important to learn about how oxygen process is managed in your region. Patients and family must be part of the process. They have to understand what is going on. The access to oxygen requires participation of patients and its family members. So that's it I would like you to know. Thank you very much, and we remain in contact.